Hello and welcome to the lecture session. Modified Euler's method. In the previous video, I have explained some of the methods to solve the problems in the modified Euler's method. This is a predictor corrector method. So in this again I am solving some more problems. Using the modified Euler's formula, solve the initial value problem dy by dx is equal to x plus root y in the range of 0 less than or equal to x less than or equals to 0.4 by taking h as 0.2 given y equals to 1 at x is equals to 0. Perform 2 iterations at each stage. So it is very clearly mentioned that we have to perform it in the 2 stages because the h value is 0.2 and we need to reach out to 0.4. Therefore, we have to do for 2 stages. In the first stage, we consider x as a 0.2 and x naught as a 0 and y naught as 1. And with the step size of 0.2, that is x naught plus h, we will be getting what is y of 0.2. Later, this y of 0.2 will be used to compute what is y of 0.4. Now let's look into the stage 1. By data, x naught is 0 and y naught is 1. So, f of xy is the given function, that is x plus root y. So, f of x naught comma y naught is 0 plus root 1, that is 1. Next, x1 is given by x naught plus h, that is 0.2. So, h is 0.2. First of all, we have to apply the Euler's formula, which is given by y1 of 0 is y naught plus h into f of x naught y naught. So that is 1 plus 0.2 into 1, that gives us 1.2. This is Euler's formula is used. So we got the value as 1.2. Now by using the modified Euler's formula, we have y1 of 1 is y naught plus h by 2, f of x naught comma y naught plus f of x1 comma y1 of 0. So we get 1 plus 0.2 by 2 into 1 plus 0.2 plus root of 1.2, which on simplification gives 1.23. Next, y1 of 2. So y1 of 2 is given by y naught plus h by 2 into f of x naught y naught plus f of x1 y1 of 1. That is, in the previous formula we have y1 of 0. Here we have y1 of 1. That is nothing but 1.23. So let us substitute in the formula and we again get the value as 1.23 because the difference between this and this is only root of 0.3. So that makes almost no difference. Therefore, we are getting y of 0.2 as 1.23. Next stage. So in the second stage, we are assuming x naught to be 0.2 and y naught to be 1.23, which is obtained in the previous step. Now, f of xy remains the same, that is x plus of root y. So f of x naught comma y naught will be 0.2 plus root of 1.23, which is 1.30. Now x1 is equal to x naught plus h, that is 0.4, which implies h is equals to 0.2. Now by using the Euler's formula, we have y1 of 0 is y naught plus h into f of x naught y naught. So on substitution of y naught h f of x naught y naught, we get 1.26. Now let us apply the modified Euler's formula given by y naught plus h by 2 into f of x naught y naught plus f of x1 y1 of 0, where y1 of 0 is 1.26. So let us substitute all these values. We get 1.512. Now second time y1 of 2 is given by the formula y naught plus h by 2 f of x naught y naught plus f of x1 y1 of 1, where f of y1 of 1 is given by 1.512. So remaining all the values are same here except this root, that is y1 of 1. Here it was y1 of 0 in the previous step. Here it is y1 of 1. So that 1.26 alone is to be replaced by 1.512. So we get, instead of 1.512, we are getting 1.52. That is the only difference. So after applying the two stages, we are getting 1.52 as our answer for y of 0.4. Next problem. Using the modified Euler's method, solve the initial value problem dy by dx is equal to log of x plus y, where y of 1 is 2 at x is equal to 1.2 and 1.4 by taking h is equals to 0.2. It's very clear that we have to go again with two stages. That is 1.2, when we take 1.2, the stage 1 will be completed. When we use this one to compute 1.4, stage 2 will be completed. So we need to compute y of 1.2 first and use this value to compute y of 1.4. So in the first stage, we are computing what is y of 1.2, and for that take the given data. X naught will be 1 and y naught is 2, and f of xy is log of x plus y. So f of x naught comma y naught will be log of 1 plus 2, which is log 3. So that gives us 1.09. And x1 is given by x naught plus h, which is 1.2, which implies h equals to 0.2. By using the Euler's formula, we have y1 of 0 equals to y naught plus hf of x naught y naught. On substitution, we get 1.218. Next, by applying the modified Euler's formula, we have y1 of 1 is y naught plus h by 2 f of x naught y naught plus f of x1 y1 of 0. So 2 plus 0.2 by 2 of 1.09 plus log of 1.2 plus 1.218, which gives us 2.197. Now let us compute what is y1 of 2 by making use of the previous value. That is, in the place of 1.218, we are substituting 2.197. That gives us 2.231. Next, this value is used in the second stage to compute what is y of 1.4. As usual, we consider f of xy to be this and f of x naught y naught will be this. And by using the Euler's formula, y1 of 0 is this, y naught plus hf of x naught y naught. After substitution of all the values, we get to 2.477. And later, this value will be used to compute y of 1.2 by using the modified Euler's formula. So y1 of 1 is given by, the formula is this, and substitute the values what we have, which gives us 2.4898. Next, y1 of 2 is given by the formula where y1 of 0 is replaced with y1 of 1. So we get 2.490. This is y of 1.4. So by applying the stage 1, we got y of 1.2. By applying the stage 2, we got y of 1.4. So in the modified Euler's formula, we will be asked to find out how to get the answer with the two stages. So two stage problems has to be learnt. Thank you.